Hello everybody and welcome back to the Golang tutorial. So in this video we're going to be talking about pointers and the difference between references and values. Now this is again a very important concept. I know I've said that about a lot of things in this series, but this one, really trust me when I mean this. This will let you kind of get into more complex aspects of Golang, and this is something that I'm going to guarantee a lot of you probably won't understand on the first try. So make sure you mess around with this on your own, you follow with some of these examples I'm doing, and that you try to listen to the whole video, because there is a lot of stuff that I need to kind of build on, and we need to start slow and then get to the end of it. But pointers allow us to do just more complex things in Golang, and they kind of relate to what we talked about in the last video when I showed you those pointers from like the variable x stored, address 3, and then address 3 pointed to whatever that variable was. This is somewhat related to that. So there's actually two operators in Golang. There's an ampersand and an asterisk, and what the ampersand stands for is get the pointer, and what the asterisk stands for is dereference. Now this seems like a weird thing, they seem kind of complicated. I'm going to show you in a few examples how they work. So if I make, actually let's just say like something like x equals 7. So there's two properties of what I've just done here. We have what's known as a reference, and we have what's known as a value. So I've said x is equal to the value 7. So our value is obviously 7. That's whatever's on the right hand side of the equal sign, what we're storing, right? What the data type is, what information we have. And then the reference is actually the location of where this data type is stored. Now in our mind, that's x. We're storing it inside of x. In the computer's mind, that might be just some other different location in memory, right? But regardless, we have a reference, which is pretty much x. It's where the value is stored. And then we have a value, and that of course is just the value, what the actual value is. So to look at the reference of a variable, so not the value, to look at the reference, we use the ampersand. So if I do something like fmt.println ampersand x, what this really says is tell me the reference of x. So what that means by reference is where is the value 7 stored? Where is the location for that? So let's have a look at what this actually prints for us. And you can see that we get some random gibberish memory location. So this is kind of how memory location looks. You go 0x and then a bunch of hexadecimals, or I think this is a hexadecimal code. I could be wrong on that, but it's some gibberish that stands for where in our computer's memory the variable x actually sits. So you see that when I did and x, it didn't give me the value x, it gave me the reference to x. So that's something to understand, and that reference we typically call a pointer. Now look what happens when I just print x. I mean, this is pretty straightforward, but we just get the value, right? The value of x. So we have the pointer and the reference, and then we have the value. And you access the pointer or the reference by putting an ampersand before whatever it is that we're going to be referencing or using. Now, this is important because this allows us to change things. So let's just look at this example. If I say y equals ampersand of x, what I'm saying is y is equal to the pointer for x. Now that does not mean that y is equal to 7, it means y is equal to whatever that location is that we just looked at. So like 0x, c, whatever, right? And that might change as we run the program. But regardless, it's equal to that location, to that pointer. Okay, so that means now, if I actually modify y, and I use what's known as the dereference operator, which I'll show you in a second, I can change the value x. Because just like I showed you in the previous video, if we have the pointer, right? If we have the pointer to where this value is stored, if I modify that value, so if I change it inside of that block that this pointer is pointing to, then any block that points to that block will be modified, or any variable. I keep saying weird names that I'm sure is confusing, but the idea is like we have x equals 7, y is equal to the pointer of x, which means we're referencing where 7 is stored. So now if I use that reference and I change the value 7, it will modify x. So let me just fmt.println x and y for you here, and now what I'm going to do is show you how I can actually change the value of x through the pointer of x. So if I do this, and I actually do asterisk y equals 8, I can change y to be equal to 8. Now, you're like, what the heck is this asterisk, Tim? You're just throwing new stuff at me. Yes, I am. What this asterisk stands for is dereference. So this says, take this pointer value and dereference it, which means access essentially the block. So access where this is pointing to, And then here I can modify where it's pointing to be equal to 8 instead of 7. Or not where it's pointing to, but I can modify the block that it's pointing to no longer be equal to 7, but be equal to 8. Now, I'm going to draw this out so this will make sense for you in a second, but just look at what happens when I do this. So let me just make sure I save here. Let's go run tutorial.go, and we get, let's have a look here. Okay, so we get 7, some memory location, then 8, some memory location. So by doing this, if I look at x, right, x changed from 7 to 8, yet here I didn't do anything with x. I mean, yes, I got the pointer here, but I didn't modify x. So I was actually able to change x through the pointer to x. So this is the idea. I'm storing the pointer in y, right? And then if I actually want to change the value of where this pointer is pointing, then what I need to do is I need to go asterisk y. So I need to dereference the pointer. I know that seems like a weird thing, but dereference it and then set that equal to some value. So now, look, what is it? X is equal to 8. And if I want to make y equal to no longer the pointer, but to like the value, I could say y equals asterisk y. Actually, that won't work because y is it's a pointer type. But regardless, I've changed the value of x through this pointer y. So that I know seems really confusing, but that is the basics of pointers, that if I have a variable, and this works for any variable, by the way, not just, not just regular variables. Like this works for mutable variables, immutable data types, doesn't matter. Like anything you can use these pointers on. It doesn't matter if it's mutable or immutable, like the previous example. But anyways, we were able to modify x, the value of x, through the pointer to x. So that's something that's interesting to note. Now let's look at an example of using a function, then I'll get onto the whiteboard. So if I say something like func change value, and I go here, and what I'm actually gonna say inside of here is I want a pointer to an int. So let's do a string, let's change it up. Let's say str, and then I'm gonna say asterisk star. Now, when you put an asterisk before a variable, when you're putting this in a parameter, what that stands for is I want the pointer for this variable. I don't want the actual value. I want you to pass me the pointer. Now, the reason you want to do that, to pass the pointer, is because I can actually modify a variable here using its pointer. But if you just pass in the value, I'll show you what happens. So let's say change value. Let's just go str. And I think I'm actually going to have to do this. I'm going to say asterisk str equals changed, okay? Now I'm going to do another function. I'm going to say change value to, and what this one's going to do instead is this is just going to take a string. It's not going to take the pointer to it. And it's going to go here and it's going to say string equals changed, okay? So let's get out of this so we can read all of this here. Let's zoom out a little bit. Okay, and now inside of main, what I'm going to do is I'm going to make a string. So where I'm going to say toChange colon equals hello, like that. And I'm going to call both of these methods and show you what happens. So I'm going to just go I guess change value toChange, but I'm going to pass inside of here a pointer. So because this first change value function, it wants a pointer. That's what this asterisk stands for. I want a pointer to a string, not just a string. I want a pointer to a string. That's the asterisk. And then what I do here is I say, okay, well, since this is a pointer, if I want to change its value, I need to dereference it. So I go asterisk star equals change, which means change the value at that pointer. So I'm doing that. And then I'm going to call that. So I'm passing the pointer of toChange, which is the string, to there, and hopefully it'll change. So after I call that, I'm going to fmt.println toChange. So we'll print it before and we'll print it after so we can have a look at what it looks like. And now let me just run this and show you what actually happens. And then we'll kind of discuss it here. So go run tutorial.go. Okay, so we get hello and then we get changed. So notice that even though I didn't change the variable toChange anywhere here, it actually got changed by this function. The reason it got changed by this function is because I did not pass the value, but I passed the pointer. So I passed the pointer, and since I had the pointer, I was able to directly modify the original variable toChange. This is one of the very powerful things in Golang, that we can pass around pointers and use this dereference operator. So now let me show you what happens when I change this to change value to. Let's see what happens now. Now I'm not going to pass the pointer this time because this one doesn't take a pointer, it just takes the string. So let's have a look. What is this saying here? Cannot use, oh no, that will be good here. So let's run this. Okay, so go run tutorial.go and notice that our variable here stays hello even though I changed it here to change in change value 2, it doesn't change. It stays to at the value hello. The reason for that is because I didn't pass the pointer. So when I'm using a variable that's immutable, like a string, right, or that doesn't have those special properties like a slice and a map, and I pass it through and I don't make it a pointer, I can't directly change it inside of here. What really happens when I do this is I say str is equal to change, right, which in this case is hello. So str becomes equal to hello when I don't pass the pointer, which means I'm really just making a copy of the string that I passed here. And if I make any change, I'm only changing that copy of the string. I'm not changing the original string, right? So if you want to do something like this, typically you're going to return a value, right? So maybe I'll say string, and then I would just return str, right? And that would work. I could return str back and then we could reassign it down here, but this won't change the variable that I passed because I'm not passing the pointer. Whereas up here, I am passing the pointer, so I'm actually able to modify it. So now let's go to the whiteboard quickly and I'll draw this out and show you the difference between these two functions and what's happening on a lower level. Okay. So I've just got on my whiteboard here. I've just started drawing a little example here just for RAM, just so we have something that's already kind of created. I don't have to draw it out in front of you guys. And what I'm going to do now is show you what happens when we actually use the code that I just wrote there. So the code was pretty much like we made in a string or something, right? I mean, this doesn't matter if it's precise, but I said something like x : equals hi. Let's just use that as the example. Then I called the function change value. So change value like that, and I passed in to start that ampersand. Now, can I draw the ampersand? That's the question. Okay, so you know what? That's going to be my ampersand. I know this is not anywhere close to what it's supposed to be, but just this is pointer, okay? This is the ampersand. Okay, so we write the ampersand. I know you guys are laughing right now in the comment section, and what I'm going to do now is put the variable x. So when I call change value with ampersand x, what I'm actually passing inside of here is a pointer. Now let me show you, right? So if I said x : equals hi, then what we do in RAM is we'll say that like this box here is x, okay? So that's x. X points to this memory address, and this memory address stores the string hi. Now forget what I showed you in the previous video with mutable, immutable. I kind of did a little shortcut there just to make it a bit easier to understand, but just imagine that x and this address are kind of like the same thing, okay? They reference this box that stores hi inside of them. So what I do when I pass ampersand x is I actually pass not hi, but I pass this. I pass this memory location. So I pass this 0x374. So really, this is 0x374, some memory location, okay? So I pass the memory location, I don't pass the value hi. Now, if I just put x there, right, so I don't put ampersand, and I call, so change value 2, like this, so let's say change value 2, then what I'm passing is x in here is not this, but it's the value of x, which is hi, right? So I hope this is making sense. So when I go to change value, what I pass is the memory location of where this value is stored. I don't pass the value itself, which means if I have this, I can modify the value. So since I got given the address, when I did that asterisk, right, and then I said asterisk, whatever we called the variable, I don't even know what it was passed in. I called it string or something, right? So when I said string and I changed that equal to something, what I was saying is change this memory block here, change what's inside of it to be equal to change, right? So that actually changed the variable x up here because x is just pointing to this little block, right? So I think hopefully that's making sense, but that's what I'm trying to illustrate here is that we have these memory address locations and we can pass those around instead of just the value. Because here, if I just pass the value, this doesn't tell me anything about the variable x. It doesn't tell me where x is defined. It doesn't tell me where hi is even created, right? Or where it's stored in the program. We just pass that value, which means when we get to that function, we say str equals x, right? So the string, which was the parameter name. I'll refresh you if we look at here. We saw string, right, which is the parameter name. So when we just pass the value, let's go back here and have a look, then we don't have any information about the variable x. So we can't change it from inside the function. Whereas when we pass the pointer, we do have information about the variable x. And if we want to access the value, we can do that. And if we want to change the value, we can do that as well. So that is the core difference between a reference and a value. And when you pass them to functions, this is what you want to think about. Do I care about the underlying memory location of where this object is? Do I care about possibly changing that? Or do I just want the value? Because there's a lot of times where we just want the value. We don't actually care about modifying the variable that was passed in. We just want to know what its value is equal to. But there's a lot of times where we care about the variable that we're passing in, right? So in that case, we want to use a pointer. So hopefully that makes a little bit of sense and that drawing kind of cleared things up. Okay, so I'm just going to summarize what we went over here. Again, this is something that you're going to have to kind of play around with and you're going to learn as you go through. But I just want to show you at least these operators, and then the next videos, this should start to make more sense with some more examples for channels and all the stuff that we're going to do. So this asterisk, when it goes to the left, to the left of a data type, what that stands for is a pointer to that data type. So this is saying a pointer to a type string. That's what that means when I do an asterisk string like that. Now, when I use an asterisk before a variable name, not a data type name, what I'm saying is get the value of this variable. So this is saying take the pointer and figure out the value of this. So if I say asterisk star, I can change the value of it because I'm getting the value and then I'm modifying it with the equal sign. That's what asterisk star does, okay? So I can change it like that. Now the ampersand, if you put that before something, that gets the address of that item, the address or the pointer to this variable. So it's not giving me hello, it's giving me that 0x memory location that points to hello, which means I can now modify whatever toChange is equal to because I have that memory location. So that is the core difference. The asterisk is known as the dereference operator. The ampersand is just get pointer. That's what that stands for. Now we can do something crazy like this too. So I'm going to get rid of this function. I'm going to show you one last example that maybe will make this more clear. So if I have another variable and I'm going to define this explicitly and I say var, let's say pointer, let's just call it that. And then this is equal to an asterisk of string and is equal to ampersand toChange. Now this is a valid line of code because what this is saying is I want to store, pointer declared and not used. That's fine. I can fmt.println it. But this is a valid line of code because what I'm saying is that this pointer variable is of type pointer to string, and then I assign this to the pointer to a string. So now I have the pointer to the variable toChange, and I can modify it through this variable. So if I print out asterisk pointer, what this does, and I know this is confusing because there's so many use cases for these things, but if I print out asterisk pointer, this will print out hello. In fact, I'll prove it to you. If we go run tutorial.go, we'll get the value hello because this is saying find the value at the pointer. Whereas if I just print out the pointer, right, then we're going to just print out whatever that memory address location is, which is 0xC4E, whatever it is, right? So we print that out. So that is the core difference there. Now watch though if I try to do this, and I'll show you that this will likely not work if I do the ampersand to pointer. So let's go run tutorial.go. And let's have a look at this. Okay, so this is interesting. So this is a different location than, okay, so let's do this. Because I got into an example that I think is a little bit more complex for some of you guys, but let me just print these out to show you. Okay, so what I've printed here is I've printed the pointer to toChange, and I've printed the pointer, the pointer to the pointer. So you can see that this first pointer here is the pointer that actually points to the variable toChange, which allows me to modify it, right? And when I did the asterisk on pointer, it gave me the variable hello. Now, I actually got the pointer of the pointer when I did this. So I said ampersand of pointer, which is a pointer to a pointer. Now, I know that seems confusing, but this is pretty much telling me where the variable pointer is storing the pointer to toChange, right? Because this is storing a value, but this variable is storing a pointer. So this is really like when I do this, I'm getting the pointer that points to toChange, whereas here, this is just a pointer that points to hello, right? So I hope that kind of makes sense. Maybe that confused you more than it needed to, but try to mess around with these things and see if you can figure out how the asterisk works and how the pointer works. Again, this is really hard to explain because We need like really good concrete examples and a long time to nail this in, and I can't do 2-3 hour long YouTube videos for a topic like this. But please do make sure you understand pointers before moving too much further forward. Although if it's a little bit like questionable, in the next videos I will be doing some more examples hopefully, so maybe it should clear things up. So with that being said, I think I'm going to leave the video here. I hope this was at least somewhat helpful to you guys, and now you have some idea of the difference between pointers and dereference operators, which I've talked about here. Again, this is a complex topic, so don't feel bad if it doesn't make complete sense. And I guess with that being said, like the video if you enjoyed, subscribe, and I will see you in the next one.